So what I like to do is show about triggering the M2k instrumentation board, and with particular focus on experiment 5 and project 2. So with that, let me go ahead and share my screen to show you the type of thing we're looking at here. Okay. And hopefully this will not block the view much. So I have Scopy running. I have an instrumented beam. And on the instrumented beam, I'm using the one that the hybrid students can use, the in-class beam. But everything's the same, whether you're doing this or building your own. My built-in own is right behind me here, same sort of thing. So this is just, there's a block there and this beam, and this can go up and down, and I can give it a pluck, and it'll vibrate, and you can't, it's about 27 hertz, so you really can't see the vibration very well. Okay, but I can do that. So now let me go up and look at Scopy. And what happens is right now, Scopy is set up, and let me just try to do a few things here, just let you know where I have it set. I happen to be 200 milliseconds per division, and depending on the frequency you're doing, you will be changing. I have 500 millivolts per division, and again, that depends on how fast the acceleration that your beam experiences as to what you want to do. Okay. I also do have the intermediate on, and that's on channel 2, and it also is at 500 milliseconds per division. If I go back to channel 1 here, and let me just go ahead and I'll give it a pluck. And you can see it's recorded a trace. I can see both signals, and it keeps going away. And I want to talk about that. But before I do that, I want to mention that for channel 1, and you can do it any channel, there is an option to avoid this DC offset that channel 1 has. So the DC offset on the accelerometer, 0G, gives you about 1.5 volts, and then it's what, 0.48 volts per G. The fact that gravity's pulling down, I actually get another G on this. So in the vertical direction, there's a G down. And so I am sitting here at, just about 1.83 volts, which given that the offset, the zero might not be exactly 1.5, that's all consistent. Okay? So there's this DC value there. That's the way the accelerator works. We can mathematically eliminate that. This is AC software, AC coupling. And if you look, what it did is it mathematically subtracted it, but you're still within the range of the signals it can record. So it can't record it can't still record up to plus 2.5 because it's actually sitting up here close to 2. Right? So it's limited as to what it can do and things like that. But it's easier to see. And if I do another pluck here, hopefully, yeah, you can see there, and it'll go away, but you can see it's easier to look at this. And so the orange, again, is the accelerometer. The violet, whatever you want to call it, is the output of my integrator. Right? So this thing sits here, and it goes away. If I just look at one, let me see if I can stop it. There, let me stop it. You can see the accelerator saturated. Okay. Now remember, if I take off the AC coupling, I think it remembers it. Nope, I have to do no scan, I'm not going to do no scan. If I think about it, it's AC coupled. It's distracting about 2 volts. So this is actually the lowest the accelerator can go, and this is the highest can go. And it's limited to somewhere near 0 volts on the output, and we subtract off the DC to near 3 volts on the output, and we subtract off the DC. So it's in there. You're seeing saturation, and you want to avoid that. And the fact that it's saturating, you can actually see the integration is also showing that the plus and minus parts of these traces are not equal in size. Where out here they are. So you get a low frequency shift, and you want to avoid all that. But I could do that by keeping my pluck pretty small. What I want to do, though, is if I look at channel 1, I'm going to say, let's trigger off of channel 1. And actually, let me just make sure it's showing me channel 1 here just so you can see it. Channel 1 have, anyway, if I look at this first swipe up here, I think a good point to trigger is about 0.5 volts. That on a sweep, that doesn't, I'm going to have to do smaller plucks so I don't saturate, but I could do 0.5. Actually, let's make it a bit lower. Let's just say, it's sitting here, it never gets left above about 0.3 volts. So if I go and look at trigger, I can now say, let's trigger, and I have a choice. I can trigger on channel 1 or channel 2. Either one would work for me, right? Let me trigger on channel 1. Right? Level. I just said, let me do about 0.3 volts. Whoops. So let me do 300 millivolts, right? 300 millivolts. And this blue line is telling me where that is. Right? So, and if I look in here, I am also doing rising edge. So I can trigger when it's rising, when it's falling, not even quite sure what low and high do. But let me do a rising edge. So when channel 1 first crosses about 0.3 volts, and I somehow changed my level, didn't need to do that. If I use the wheel, it does weird things on me. So I should use this bar here, not the wheel. Okay. The first time it crosses 300 millivolts, it should trigger. Okay. So that all looks good. Let me turn it back on. And see how it says it's waiting here. Okay. However, it stopped waiting. It actually triggered when I didn't do anything. It's waiting, and then it triggered. So what it's doing is up here, I look at auto. Auto says, okay, you have a trigger level, but if I don't see a trigger, eventually I'm just going to trigger it anyway. So if I go to normal, it says it's waiting. And this can be frustrating if you want to know what the DC voltage is or something like that, but it's waiting, right? So now I'm going to give it a pluck. I'm going to try to make it a smaller pluck. And you see it triggered, and now it's waiting again. My pluck was still a bit too big. If you look, I've still saturated on the positive end of it. And again, it's offset because of 1G. I could move this beam, turn it 90 degrees, so it doesn't have force of gravity pull in the Z direction, but I don't need to do that. I'm just going to leave it like this. So this allowed me to get a trace, and it's not triggering again. So I have time to look at it and stuff like that. Now, if I'm worried about the fact that maybe something's going to bounce and luckily, yeah, and I'm going to get false triggers, right? What I can do is, again, I'll do another pluck, hopefully get a good signal. I did, and then you can just stop it, right? If I stop it, it's going to sit there and I can see it. Then there's some other things I can do now, and hopefully that gray box you're seeing is going to go away. I can say, well, this is good now. I'm going to get this trigger. I'm kind of more interested in the part of the signal that's out here, right? So, you know, did I stop it? Yeah, okay. Stop. Okay. Okay, so it stopped. So what I can do is I can go back to my channel 1 and say, okay, my 0 position's in the middle. And I'm not that interested in this part out here. Right? So, but what happens, just so you know, what happens is the M2k is always recording stuff. It's always recording about 8,000 samples. And when the trigger hits, it says, okay, I'm going to keep those 8,000 samples, and then I'm going to record more out here. So that's why you see, here's the trigger. I see the history before the trigger. I can say, well, I really don't need all that. And I'm going to go, you can just slide this out and say, you know, let's trigger some other plates, you know. The problem I have over here is when I do that sort of thing, I end up with funny numbers here. So let me just pick in here a number that's maybe a little more useful. And I'm going to use 500 milliseconds, right? And so it doesn't look all that great or anything right now, but let me go ahead and tell it to run. And I'm going to give another trigger. I'm going to be practicing giving smaller triggers or smaller plucks. Okay, I still saturated, so it's still a little bit big, but not too bad. And you notice what it did is, here's my 0 is way over here. And so what I can do is say, okay, I'm interested in this part out here. Let me go ahead and change the time base. And I didn't, let me go to 100 milliseconds. I'm not quite sure why I changed it quite that way. And let me try another trigger. Okay, so if you look now, again, I say put my 0 over here half a second. So this, if you notice, the middle of the screen is now 0.5 seconds, right? And 100 milliseconds per block. So here's 0, here's 100, 200, 300, 400. It's now easier for me to see cycles of this. So I'm playing games with both the time base and the position to do this. And again, my goal would be to get a pluck where I don't saturate. And that I could actually use that one. It's not bad. It saturates on the first few. I can go ahead and work with that. I could go a bit smaller yet. And since I'm going smaller, I could actually try and go, let's see what happens. Well, no, let me just leave this one alone. And again, just try to get small plucks until there's probably a good one. And I could export that data and use it in MATLAB. So I can play around with it, both by setting where T0 is going to be, by setting the trigger level, things like that. Now, if there was a lot of noise, there is the option, and it's mentioned in the document, of doing a single scan. Okay? Single scan means that when I pluck it, okay, I do a pluck again. That was a big pluck. Okay. Now I can sit here and pluck it all I want. It said single scan. It stopped. It's going to ignore any following noise. So that's the advantage of single scan, right? So if I say another signal scan, now it says it's waiting, right? And so with waiting, it's not going to do anything until I do a pluck, and now it's stopped. Okay? Versus when I did run, okay? Again, if I ended up with some noise, it found the noise triggered it. And, so I had a good scan, but then some noise came along and it took away my scan, right? So that's the advantage of single scan. You don't need it because the signal's so good compared to the noise here. So, on this one, as long as I don't do that sort of big noise that I made. And again, I would say that's a very good signal for both the accelerometer and the integration. Again, what I looked at was my settings for channel 1. And on channel 1, I took advantage of the fact that I can do this software AC coupling. And if I turn that off for a second, this stuff sort of works. But of course, now my trigger level is an issue. So I'm not going to go through all that again because it's waiting for this signal to get way down here, and I'm not sure if it ever will. I could have used the other channel. But anyway, software AC coupling, it doesn't change your saturation points, but it does allow you to take away that DC, which can be a bit of an issue for these. And why vertical 500 millimeters division, oops, I think position, that's the position is an issue. I keep trying to use my mouse wheel to change things. Okay, so AC coupling's on. I think I was still on single scan. So what else did I change in there because I'm not getting close right now? Let me just again look. Time base, I noticed that at 500 millivolts per division. AC coupling on. Okay, we'll take a look at the trigger. trigger is normal, so it waits for a signal level 300 millivolts, which produces. And I don't actually need to worry about these other parts of it. And I have it, tell it to run. That was my problem. I stopped the thing. Tell it to run, do a scan, there I am again. And again, now another scan is just going to work again. But as long as my noise is not big, I can let it sit there and I can export that data. So some information about running Scopy and the M2k. Let me also mention while I'm here, power supplies, I have to have mine. That's supplying my integrator chip. I'm using ±5, right? Signal generator, I have to have it on. If I look, channel 1 is sitting at a constant of 3 volts. That's powering the accelerometer. And an accelerometer does not like 5 volts. I give it 3 volts by using that signal. Right? And if I go back to the oscilloscope, here again, you can see my beam and my oscilloscope, and you can see the type of trace we're looking for. So I hope that helps, and I will go ahead and stop the recording.